So students, on the right hand side where I'm marking by pen, so there is another question which I left it half done in my earlier lecture. So I'm first trying to complete it. So as you see here, this is a coil which is an inductance of 5 Henry, and the current is in this direction and it is decreasing. Di by dt is given as minus 2 amp per second. So basically the current is going down, right? It's getting reduced. We have to find the induced EMF and we have to find Vp minus Vq, the potential difference between these 2 points P and Q. Now, the basic formula, so if I go by basic formula, I know E is equal to mod of L di by dt, correct? So if I just put in the values, it becomes 10 volts. Now this whole thing can be written in this fashion, like basically it is I can write it in this fashion. This is P, this is Q, and this basically is the coil which is behaving like a battery now. Okay, and this is 10 volts. Now why this direction? So because this is reducing, so the current will remain the same in the same direction. Now to put this in the same direction, it should be from positive to negative, correct? Right, and this should be the battery. Okay. On a similar note, there is another question as you see in the paper right now. Now here it has been given that this is decreasing because di by dt is minus 5 ampere per second, and we have to find Vp minus Vq. The first step would be E is equal to mod of L di by dt, correct? Or I can write it as 2 into 2, 4 volts. Now if I draw this, it will be something like this, and P, this is positive, negative, and this is behaving like a battery, and we can say VQ is greater than VP, and we can say Vp minus Vq is equal to minus 4 volts. Now we will look into an alternative method of doing this. Alternative method. Now the alternative method is, look at this. See, the current is flowing in this direction. So let's say it is Vp, correct? Now when it is flowing in this direction, there would be some drop here. So use that with sign. So I can write L di by dt, correct, is equal to Vq, simple. But use this with, don't use mod, use it with sign. Okay, I can say then Vp minus Vq is equal to L di by dt, or I can say 2 into minus 2, which is minus 4 volts. Okay, so that's an alternative way of doing it. Now let me take another question where it's something like this, as you can see, and this is A, this is B, current is flowing in this direction, L is equal to 6 Henry, and let's say di by dt is equal to 4 ampere per second. Now we have to find VA minus VB. So here is the solution. If we do it by, see, it's flowing so in the opposite direction, so I will say VB minus uh, di by dt, L di by dt, correct, is equal to VA. Or we have to find VA minus VB, take it that side. This becomes or I can say VA minus VB is equal to minus L di by dt, right? Now if I put the values, L is 6 Henry, minus 6 into 4, which is minus 24 volts is the answer. So students, now we would be talking about coefficient of self-inductance for a long solenoid, right? I have drawn a small solenoid here, because of the scarcity of the place. Let's say the radius of each coil is R. N is total number of turns. Now we have read this. Small n is equal to capital N by L, right? This we have, which is number of turns per unit length. So number of turn per unit length. Okay, now we know the magnetic field in this solenoid is in the direction of axis. We have studied this, right? So B is equal to mu naught Ni. This is what we derived, right? Now magnetic flux with each coil is equal to BA, which is BA cos 0. Now why 0? Because it is the magnetic field is through the axis and area is also in the same direction, right? So the angle between them is 0. So cos 0 is 1. So I can write it BA. Now phi is equal to mu naught N I pi r squared. Total flux, let's talk about total flux now. Total flux, let's denote it by phi t is equal to N phi. Now N is nothing but NL, so NL, correct? Now I'm just putting this, which is mu naught Ni pi r square, or we can say phi t is mu naught N square pi r square Li. Okay, but we have studied, if you remember, phi is equal to Li. We have studied this, right? We have studied phi t is proportional to I. You remember last lecture? Then phi t is equal to Li. Let's replace this here. So Li is equal to mu naught N square pi r square Li, right? Now if we deduct it, I gets cancelled and we are left with L is equal to mu naught N square pi r square L, right? And this is the derivation. Okay, so yeah, this is a very important result and you guys need to remember it, because at times they give a numerical based on this in the main or board exam. Thank you.